Number 18 says, evaluate the following integral by using part 2 of the fundamental theorem of calculus. Part 2 of the fundamental theorem of calculus states, if we have the integral from a to b of f of x dx, where f is continuous on the closed interval of a to b, then the integral from a to b of f of x dx is going to equal to capital F of b minus capital F of a, such that lowercase f is equal to capital F prime, and the limit exists. That may seem like a lot, but the main thing is the integral means antiderivative. So I'm taking the antiderivative of this function between 0 and pi over 2 of 5 cosine of x dx. So that should be pretty straightforward because a cosine function is continuous on the interval from 0 to pi over 2. What I'm going to do is I'm going to move the 5 to the outside of the integral. So that's going to be 5 times the integral from 0 to pi over 2 of cosine of x dx. And now I'm taking the antiderivative of cosine. The antiderivative of cosine of x is sine of x. That's going to be 5. Let's put this in brackets. The antiderivative of cosine of x, that is going to be sine of x. And we're going from 0 to pi over 2. Once you take your antiderivative, you're going to plug the value of b, which is pi over 2, into your antiderivative. And then you're going to subtract that from when you're plugging in the value of a into your antiderivative. So that's going to be 5 times, in brackets, we're going to have sine of pi over 2. And that's going to be minus sine of 0. Five, we can use parentheses now. Sine of pi over 2, that's 1. Minus sine of 0, that's 0. 5 times 1, 5. That's your answer. If we go to the next one, we're taking the integral from 2 to 8 of 12x squared minus 100x plus 1. So we're going to take the antiderivative of that. So to take the antiderivative of 12x squared, we're going to add 1 to the exponent and divide that by 2 plus 1. That's going to be 12x cubed over 3. And that's going to reduce to 4x cubed. I'm going to put a bracket right here. Now we're going to do the same thing for 100x. There is an invisible 1, so we're going to add 1 to the exponent and divide that by 1 plus 1. It's going to be minus 100x squared over 2. And that reduces to 50x squared. The antiderivative of a constant is going to be the constant times the variable to the first power. So that's going to be 1x. The antiderivative of 1 is 1x, which is just going to be x. So plus x. And we're going from 2 to 8. Now we're going to do the fundamental theorem of calculus. Plug 8 into the function first. So that's going to be 4 times 8 cubed minus 50 times 8 squared. And that's going to be plus 8. Close that parenthesis up. Then you're going to subtract that from when you're plugging 2 into your function. So 4 times 2 to the power of 3 minus 50 times 2 squared plus 2. All right, so let's plug this into our calculator and get our answer. Do one set at a time. So that's going to be 4 times 8 to the third power minus, that's going to be 50 times 8 squared. And that's going to be plus 8, which is over here. So that's going to be negative 1,144. That's going to be minus, keep this in parentheses when we do it. And let's replace our 8 with 2s. So delete that, put a 2 here. Delete that, put a 2 here. And remember to delete that part as well and put a 2 here. That's going to be minus 166. And let's subtract. Negative 1144 minus, well, it's going to become, well, let me start over now. Negative 1144 minus parentheses, negative 166. That equals to negative 978. And that is the answer to the question. All right, guys. Hope you enjoyed it. Hope you liked the video. I'll catch you soon. Take care.